In today's video, I'll be showing you this tutorial. It's going to be a vertical louver system, and the idea is to show you practical uses of Grasshopper. So on this one, you can change the number of vertical and horizontal subdivisions for the overall frame. But you can also see here that we have this louver system, which at the end here, you'll learn how we can rotate this to whatever angle. We can also change the subdivision type. So we have here more or less subdivisions. We can change this and then increase the subdivisions this way. And so I just wanted to show you the power of what we can do with parametric design. In this one, I'm showing you how to create the structure, like I said, the vertical subdivisions, and how to apply it to any surface. So we have it applied to this surface that we can change the location, we can set a different surface, and that is one of the benefits of using something like Grasshopper. So if you're excited to learn a little bit more about how this works, I'll have this script available on my website. If you don't want to watch the tutorial and you just want to see how things plug in, you can always go there and see it. I have it available for a limited time initially. But if you're watching this and you're subscribed, you should be able to download this. If you have any questions, let me know in the comments below. At the end, I'll also show you how to render this using an AI render. But for now, I want to show you every single one of the steps for creating this. So with that being said, thank you very much for being here, and let's jump right into it. All right, so in today's tutorial, I'm starting out with a base geometry that I've created for this example. We have a ceiling, a roof, a floor, and then we also have the floor below, as well as a window. So this is more of a curtain wall system or a storefront system where we have frames and glass. Now, for the tutorial today, we need to be creating a vertical louver system. So what we need to do is bring into Grasshopper a surface that will be what we will develop for this design. So what I'll do here inside of this model is go to extrude curve and extrude this up. Then I'll take this and bring it into Grasshopper. But first I will move this in, let's say by 1 foot. So now that we have this moved in, we need to bring it into the Grasshopper interface so we can start developing it. First thing we need to do is go here and double click, bring in a surface component. And for this surface component, you'll see that we'll be using this empty surface component that could be found here under the primary or parameters, geometry. And in here, you'll see all of the empty parameters or empty components that we can bring geometry into. So with this surface, we can select this surface here. And notice that it's an orange component, which means that it doesn't have, or it's missing some information and it's not working yet. And when you click on this bubble or hover over it, you'll see that it says that there's a surface failed to collect data. So what we need to do is bring in this surface into Grasshopper. We'll right click into surface and go to set one surface. Now you'll see that it turns red. And when you select the component, it'll turn green, which means we've successfully brought it in from Rhino into the Grasshopper interface. And now inside of Rhino, I can hide that surface and we can get started with our design. So now that we have this, for this particular tutorial, we're going to start by creating a basic subdivision using isotrim. And this is one that I've gone over before, but the idea is to be able to use a rectangular subdivision. So we'll use this surface as the surface input. The domain will go to divide domain squared. And now we can plug in the surface into the domain input and the segments into the domain input for isotrim. Now you'll see that we have a set of subdivisions by default. The U and V are going to be 10. So let's bring in a new slider of 5. And then slide down, tap Alt to create a copy, or Control C, Control V to create 2 sliders. This will let us subdivide this vertically. So we'll leave it at 3 here, and then 5 horizontally. Actually, these are going to be the vertical ones. So the U is going to be the vertical subdivisions, and the U count is going to be the horizontal divisions. So we'll leave it at 3 and at 8. Now we're going to take this surface and we're going to create some frames where the design is going to be. So first, we'll go to Offset Curve. By default, it will offset to the outside. So let's bring in a negative component and offset them to the inside. So offset by, let's say 2.000. And what we need to do as well is we'll offset it by 0. So we'll copy this, unplug the negative component using Control to unplug, and you'll see a minus sign. And now in here under distance, we'll go to set one number to 0. And the reason why we do this is to be able to keep things organized in the sense that instead of just plugging in this surface, we do want to plug in a curve, and this will make it so we're using 2 of the same components. Now let's change this distance to 0 and then commit changes. And notice now that when I plug in a boundary surface between this one and this one, this is a grafted set, which means you'll see a dashed line. Same with this one, which means that each corresponding offset is now going to work together. So now we'll take this and extrude it in the negative Y direction. So that's going to be down here. We'll see that it's the Y direction, negative Y. But also, we need to know that this surface may be oriented in a different way in a different exercise. So if we want to use this again, we do want to use a evaluate surface and create a reference plane relative to the surface direction. So we'll use the surface as the surface input for evaluate surface, and then we'll use a point in the middle. Now we can use an MD slider, but I actually like to do this. Quotation marks, 0.5, comma, 0.5. This will give me a panel that gives me a point that's set at 0.5 and 0.5. And notice that when we click on this, the 0.5 and 0.5, it's not going to show up until I reparameterize. And it will show up exactly in the middle, looking at this surface as from 0 to 1 at 0.5 and from 0 to 1 at 0.5. And put together, it puts it exactly in the center. So now using this reference plane, we can now extrude this surface. Now you're going to be asking, how do I use this frame to extrude this? Well, you can go here to Vector, Plane, Deconstruct Plane. And now we're using this frame, the X, the Y, and the Z. And now we can go to Amplitude, of this frame, and then extrude this surface in that direction. So now we need to plug in the amplitude, or by how much we're going to be extruding it by, and then let's go here and plug in a number for the slider. So notice that it's extruding in the opposite direction. So it's extruding in the opposite direction we want to. Now, if that's the direction you want it to extrude, that's fine. But in my particular case, I want it to be in the other way. Now we can go back here and see that we have these subdivisions, and that's what's going to determine our division for the overall frames for the louver system. So let's decrease this one a little bit. Okay. So now we're going to go back to this frame that we offset to the inside, and we can disable the preview on mostly all of this because these are steps that happened earlier on in the process, and even this original surface. And now that we have this plane, we can create a surface using boundary surface here. So using boundary surface, we can recreate the surfaces on the inside of each panel here. So for the next steps, we can do it to all of them at once, but it is a good idea to go to list item and just pick one of these panels to create the subdivisions, and then we can apply it to the rest of them. Now, this is a grafted set, so we need to flatten the input. So we are looking only at one. And now we're going to take this and we're going to move it to the middle of where this extrusion is. So where is that? If we know that this extrusion here is 6.8, or let's make it 6, we know this needs to go 3 to the center, and it'll be tied to this number. So let's move the panel in this direction, but now it's moved all the way to the end. And rather than moving it all the way to the end, we can do a divide by 2, which will give us a division component with an empty A parameter, which it'll tell us here, input parameter A failed to collect data, which means we need to plug in A. And for B, it's 2. So if you did /5, it'll give you B as 5. If you do /10, it'll divide it by 10. So that is a quick way in which we can take this vector, -6, divide it by 2, -3, and now we can use that to move it. And what this will do is no matter where we extrude this to, this will always fall in the center. Now we're going to take this and use a subdivision. So we'll go to isotrim again, but rather than having to copy and create all of this again, we could just bring this and copy it to here, as long as you have a relay. So I created a relay, which means that there's more than one output coming out of this. And now we can plug this one in here and we can preview it since we didn't have it previewed. And now we're going to subdivide this vertically, but not horizontally. So let's increase these and then decrease the horizontal subdivisions. So now we've created all of these subdivisions that are vertical. And now we can hide this input. Now what I meant earlier by let's just do it to 1 because we could do it to all. Once we subdivide this one, if we take this graft or this flattened set and we unflatten it, notice that it will do it to the rest of them as well. So this is why we can just select one item and we can do this to just this one and make sure that it applies to the rest. Next, what we're going to do is take these and rotate them. So first, what we can do is extrude it. So we will extrude these surfaces. In which direction? Well, we're going to have to go back here. And rather than using extruding it by 6, we're going to copy all of this over here. And first, we're going to move these subdivisions in the negative y direction, not by 6. We'll do it by 1. And so we'll see here that we moved it by 1, and we can see that because if we change this back, you'll see that it goes from 0 to 1. And now we're going to extrude it in the opposite direction by twice the amount. This will make the original surfaces as the center, and that'll make sense in 1 second. So we'll take this and we will extrude these surfaces. In which direction? Well, in the negative, this vector direction by 1, and then we'll do times 2. So instead of negative, we'll do positive times 2. And in the same way that you could do divide by 2, you can do star 2, and it will give you a multiplication by 2. You can do star 10, and it'll multiply whatever number is plugged into A by 10. So we'll use this vector multiplied by 2. And now in which direction? Well, it's going to go in the direction of that vector in the positive direction. So what that does is sets this as the center. And let's hide all of this so you can see exactly what I mean. That sets this original subdivision in the center. It moves it by 1 and it extrudes it by 2. So keeping this in the center. Now, the issue is that if we do move it this way by 1 and extrude it by 2, this is actually 2 inches thick. So we need to do amplitude, this dimension divided by 2. It now does, if this is 1, this is 0.5 and extrudes it by 1, setting this as the center and this as the overall depth of it. So now let's hide this. Next, we're going to plug in an area component into all of these. So we can have the exact center. And now we can create an X, Y plane at the center of each and every one of those. Why? Because now we can take this centroid and this plane relative to the center of all of those and rotate this object, which has all of these planes. And now we can set the angle. So by default, it's going to be 0.5 times pi. And so we want to change it from radians to degrees by right-clicking the angle, set it to degrees, and let's go here to 0 less than 180, letting us create a slider that is a custom slider that starts at the lower limit of 0, upper limit of 180, and now we can plug this into the angle. Now at 0, it's not going to rotate, but as we rotate them this way, it will rotate them all the way to 180. Now, if you don't like the direction that it's rotating, you can always go to, if I'm not mistaken here, let's see if it'll let us do this, reverse, and it'll actually do the opposite here. So if we switch reverse, well, either way, it's only going to do 180. So let's move it here, let's say to 45 degrees. And now we need to hide this one, bring back the frame, and so the power of using Grasshopper is that you can do a lot of things. You can do one thing to a lot of objects at the same time. So with this one, we see that we did it to this one. Now we want to do it to the rest. So we'll go back here. Instead of flattening the list, which means it puts it on one list and we only picked one, now we want to do it to all of them at once. So we'll remove flatten here. And as you can see, now we can go back to the angle and it'll switch it to all of them at once. So now let's go here and create a geometry component, which I like to just set the final sets to in here. And now we can hide all of this. and I'll group this one. And when you group something, you'll see that it gives it a color. By default, I have mine as green, like lime green. You can set any color as your default color. And this way I know that this is going to be an output. So I like to change this to the louvers. And then here, for the frame, I like to, once again, geometry component. This is going to be empty. It's going to ask what to plug in. We'll plug this in, and we can disable the preview on the rest. Group it again, and then change this to structure. Now let's go to a custom preview so we can look at this with some materials. I like to just use a color swatch and represent the material that I would want just by using just colors here. So let's say it would be some wood color, and then disable the preview on this one. Let's see. If you go to orange, and now the same thing, I'll do it to the frame. So I'll take this, slide it to wherever I want it, tap Alt, and it'll create a copy. And then plug this in, disable the preview, and then make this one dark gray frame. Now, what's great about this is if we don't like how many subdivisions we have, we can always decrease them, make them larger. This is going to be the depth of it. So if we want it to be very thin fins, we can do this like by changing this one. And if we want this to be more of a larger frame, we can do them like this. Or do more vertical subdivisions. Or the opposite, where we only have one. We have a lot of subdivisions like this, and then more subdivisions this way like this. And then from the inside, we can change the orientation. Maybe they are mechanical ones that changed throughout the day. So in that case, in here, you would have some kind of motor that rotates relative to where the sun angle is. So let's decrease this. The angle is at 90, which means it's basically fully open. But what's great about it being 90 degrees is, let's say in the morning, you'll get no sun coming in, and in the middle of the day, you will get more sun coming in. So then it can change maybe to a different angle to have some of the bounce light come in and be more indirect, and then maybe change the angle once again during more of the afternoon sun. And so we have all of these parameters that we can play with. We can create another subdivision here by doing 2 of them. And so really that is the power of using something like Grasshopper, is if you know what you want and you want to be able to see all the different options depending on what final outcome you might want, this will let you see all of the different options. So let's organize this by going to, this is going to be vertical. Structure. Horizontal. Structure. I'll group this one and then group this one separately. So I know those are components that I can change. Then here it's going to be frame size. So if we want it to be a very lightweight frame, we can make it thinner. So this is going to be structure size. We can hide this as well. And this is looking okay. I just don't like some of the wires overlapping and creating confusion. So I do like to go to wire display hidden. You can always select it and see where that vector came from. This is going to be for how many divisions we have this way. So we'll just go here to 1. HDiv, and then VDiv. Now I'll keep this horizontal one as 1 because we actually do want it to be just 1. Although we could change it, but what I'll do is I won't group that one together. And this one is going to be the louver depth. Here I'll do the angle. And so that's going to conclude today's tutorial. It's a pretty straightforward, practical use case of using Grasshopper, where you can subdivide a surface, and now we can take that surface and place it anywhere. So let's do that. Let's type in show, take the surface and move it out here. Notice that wherever you move that surface, so I'm actually deleting that one, wherever you move that surface, it is going to create that louver system. So if we were to create one here using this line segment, extrude this up, we can set one surface and it will create it here. Now in some cases it might extrude in the opposite direction. You can select that surface and type in flip. And now it will flip the direction in which the surface is oriented. So let's go back here. Take this, extrude surface, or extrude curve, and go to set one surface, and then move this back this way. So what I'll do is I'll have this tutorial available. Oh, actually, this is going to be structured depth. So I'm going to have the script available for you guys for a limited time. If you want to see how things plug in, or if you got stuck somewhere and you want to see how it was created, this will help you a lot. I'll also have the 3D model. I typically just do the script, but on this one, I'll also have the 3D model along with the script, so you can have this for reference. If you have any questions or you got stuck somewhere, you can always send me a message on my website, gopettidavid.com. And if you like this video, share it with your friends, give it a like, and consider becoming a member where you can download not just this script, but the library of scripts that I have available. So thank you very much for being here. Now I'm going to take a capture of this and show you how I render it using an AI render, so you can visualize this with materials and everything. So thank you once again for being here, and I hope to see you in the next one. All right, so this is a capture that I got by using ReRenderai. It is a new tool that you can sign up. So if you want to sign up, you can see that in the description below. You get a discount code. But what I like about this is that you can take a simple capture like I did with this one. This is not even rendered. This is just a screen capture of my 3D model and my Grasshopper baked geometry. And I brought it into ReRenderai, and it was able to give me a few different iterations as to what it would look like in reality, staged with a building and applying materials. So it's a great way for you to be able to quickly visualize your designs. And if you want to get started, I would recommend you using, like I said, the discount code. I feel like this is a great way to kind of jump into the world of AI rendering.